Section 11.5 Alternating Series. So in this section we will talk about how to check that an alternating series is convergent or not and what is an alternating series. Before that, what have we done up till now? In this chapter we have learned how to apply the divergence test and what does that do. That kind of helps us rule out that if a given series is divergent, so that we don't have to check whether it is convergent or not. So divergence test, it is easy to apply and you just have to take the limit of the general term and check whether it is 0 or not 0. Then we have integral test. Well, that is not very easy to apply because we have to actually calculate or evaluate the improper integral 0 to infinity, 1 to infinity, f of n dn. Then we have a p-series test, which is pretty common and easier, simpler to work with. And we have to just check if the series looks like 1 over pn to the p. If p is greater than or equal to 1, the series, if it is greater than 1, series will converge. If it is between 0 and 0 or 1 or in between, then it will diverge. Then last thing we did was comparison test and limit comparison test. So these are the series, the comparison and the limit comparison. It only works with positive term series. The series p series also works with positive, and the integral test also positive because we are going from 1 to infinity. So what is an alternating series? Well, it is a series something like example here. So you have -1 raised to some power, and then we have some quantity here to evaluate, in this case 1 over n. If we expand this series, it looks like 1 minus 1/2 plus 1/3 minus 1/4 and so on. Now look at this. This is something similar to 1 over n and goes from 1 to infinity, which is called the harmonic series, but all its terms are positive. So this is a positive term series, but the one that I am talking about is the one with the alternating terms. Alternating signs. So that's a alternating series. So in this case, we say the consecutive terms an plus 1 and an have different signs. So we have an alternating series test here which we can apply, and the test works for series of this kind. So we have summation n is equal to 1 to infinity, -1 to the n, bn. Now what is bn? You can think of bn as an, because if the series is summation an n is equal to 1 to infinity, then this is summation n is equal to 1 to infinity minus 1 raised to some power times bn. So bn is nothing but the absolute value of an. So what is the alternating series test? That we have to check these three properties or three conditions. If these conditions are satisfied, then we say that the alternating series converges. So the first one is that the bn's must be greater than 0, not equal to, not less than. So bn must be, so each term in the series, the absolute value term must be positive, which of course absolute value is always a positive, but it shouldn't be 0. Then the next step is that the bn plus 1 should be less than or equal to bn, means the term of a series should be smaller than its previous term. So it should be decreasing to a number. Should be a decreasing series. And the third is that limit of the Bn as n goes to infinity should be equal to 0. The limit of a general term of the absolute series must be 0. If these conditions are satisfied, then we say that our alternating series converges. So for example, the series we have up there, look at it. Now we have Bn will be equal to 1 over n from this series, and the Bn plus 1 will be 1 over n plus 1. So let us see if it satisfies these three conditions. The first one is that Bn is greater than 0. Is that correct? Yes, because Bn is 1 over n. 1 over n is always greater than 0. And then Bn plus 1 is 1 over n plus 1. And we know that 1 over n plus 1 is less than or equal to 1 over n. Now, if this is not like quick and clear, you can always look at it like this. What is the Bn plus 1? Bn plus 1 will be, 1 over n plus 1, right? Bn plus 1 is 1 over n plus 1. So now n plus 1 we know is always greater than n. So 1 over n plus 1 will be less than 1 over n. Which means Bn plus 1 is less than Bn, which is what we want. And the third is the limit of a 1 over n, or limit of Bn as n goes to infinity is equal to 0, which is true because limit of 1 over n. So therefore, because by alternating series test, our series converges. So you can say so by alternating test, or you can say so series negative 1 to n plus 1, 1 over n, and goes from 1 to infinity, converges by alternating series test. Or you can say alternating series test colon the series converges. Now you must use the test by name. In any problem that you are using a test, you must mention the name of the test.